This is a Dell Vostro 3470. I got a phone call this morning to say that this was no longer booting. So when I plug it in here, the power supply is right here. We look at the front, I press the power button and nothing happens. If we look on the back, we can see that the LED is not on. So I'm going to take out this power supply and see if we can find out what the problem is.
Working on electronic circuits comes with a risk of serious injury. This video is for educational purposes only. Please do not attempt to work on any electrical circuits unless you have the required training and experience. Do not attempt repairs yourself. Thank you. This is the switch mode power supply from that Dell Vostro, and as you can see we have two pins here where our mains voltage comes in. We have a live pin and we have a neutral pin. Before troubleshooting this board, I discharged the main filter capacitor and confirmed that there was no residual voltage on any of the other capacitors on the board that might cause me any harm. Since there was no green light on the back of the power supply, I thought we should first check the AC input and see if the fuse is possibly blown there. So from our live pin, we can track the path of our live signal onto the board. So let's do that now. So first of all, as you can see, it comes across here. I'm going to mark this in as we do it. Then it comes across a fuse at this point right here, which we need to check. The live then comes down around here and up to this point here. Now this is where it goes across an inductor and jumps over to this side right here. I'm going to mark in the inductor just with the common inductor symbol. It travels around this track and comes back down to here, where it jumps across a second inductor and then comes onto one of the center pins of our bridge rectifier. So now that we've confirmed the live path, we just really need to confirm that there's continuity through that fuse, through the inductor, through the second inductor, and the whole way to our bridge rectifier. So I'm taking the following measurements with all power disconnected from the board and all of the capacitors fully discharged. So we introduce our multimeter in diode mode, and I place my red probe to the live input and place my black probe to the center pin of the bridge rectifier, and we find that it measures 0.00. So we have continuity. The fuse actually is not blown. I was almost certain it was blown, but there is no issue with the fuse. Next, I'm going to confirm the neutral path. So as you can see, we have an N for neutral here. The neutral comes along this track here and up to this point here. We're going to mark that in, and it comes across an inductor to this point here. We're going to mark in the inductor. Next, it travels onto a second inductor, and then when it jumps that, it then travels onto the other center pin of our bridge rectifier. So once again, we just need to confirm that there's continuity from where our neutral pin connects to the board to the center pin of our bridge rectifier. Let's do that now. So once again, with our multimeter in diode mode, I place my red probe to where our neutral signal comes in, and I place my black probe to the other center pin of the bridge rectifier, and I find that it measures 0.00. So we've continuity the whole way from where the neutral wire comes in to the other center pin of our bridge rectifier. Now the purpose of this part of the circuit with these inductors and these capacitors right here is to prevent RMI and EFI noise from entering or leaving this switch mode power supply. With those few simple tests that we've carried out just there, we have confirmed that our live path is good up to our bridge rectifier for both our live and our neutral. So the next component in line is our bridge rectifier. Now the bridge rectifier can be 4 discrete diodes, but on a lot of these switch mode power supplies is a 4-pin package. So you can see we have 4 pins in a line here, and that is the bridge rectifier. If we mark in the pins on that, you can see we have 2 center pins where our AC voltage comes in, and then 2 outer pins where our DC voltage comes out. And to help everybody, including myself, understand what measurements we're taking next, I've marked in the diode configuration for that 4-pin package. So as you can see, within that 4-pin bridge rectifier, we have 4 separate diodes which can be measured separately. So let me show you the measurements that I took from that bridge rectifier. I've zoomed in so that we can see the outline of the diode configuration in that package a little more clearly. I've drawn this in because it helps me to understand the measurements I'm taking. I'm hoping it's the same for you guys. If you find this drawing of the diodes on top of the bridge rectifier pins confusing, just put it down in the comments below. But the purpose of me doing this is that we can now see where we measure each of the individual diodes within that package. So to take a measurement for this diode, all we need to do is switch our multimeter to diode mode and take a measurement from this pin to this pin. To measure the second diode, we measure between this pin and this pin. To measure the third diode, we measure from this pin to this pin. And to measure the fourth diode, we measure from this pin to this pin. So let me show you the measurements that I took. Once again, I feel the need to reiterate that all of the measurements I'm taking here are with the power disconnected completely and with all capacitors on the board completely discharged. So the measurements that I took for each of these diodes were as follows. For the first diode, I measured 0.532. For the second diode, I measured 0.534. For the third diode, I measured 0.538. And for the fourth diode, I measured 0.540. So all of the diodes within this package are fine. So we have established at this point that all of the AC part of our circuit seems to be good right up to our bridge rectifier, and our bridge rectifier seems to be fine as well. So what I'm going to do here is I'm going to remove all of the markings on the board that I've put in relation to the AC. I'm going to remove the diodes as well. And what we're going to do is follow the next part of the circuit from where the DC comes out of the bridge rectifier. So our positive DC comes out here and our ground DC comes out here. So let's mark in the paths that they take up to the main filter capacitor next. Our DC leaves the bridge rectifier here and comes along and across a thermistor at this point. So let's mark that in. The other side of the thermistor, it comes along this track and onto a diode. And after the diode, it comes down to a jumper across here and onto the positive pin of our main filter capacitor. On the ground side of our bridge rectifier, you can see that there's a jumper across from here onto this track, so let's follow that. From there, it comes around this track here and jumps across to here and onto the ground side of our main filter capacitor. So we've identified the two pins of our main filter capacitor. Now these large filter capacitors can fail, so the next thing I wanted to do was just to discharge it completely and take a capacitance measurement across these pins. When I took a capacitance measurement here, I was getting no reading at all. So I decided to take it off the board, measure it off the board and just confirm if it is actually working or not. So I've removed that capacitor from the board and I'm just going to test it with my Atlas ESR 60, and as you can see, it's not reading it at all. And just to prove that my meter is working, this is a spare capacitor that I pulled out of a spare board. And as you can see, when you have a working capacitor, it does an analyzing check and then gives you the capacitance. So it looks like the capacitor that I took from that SMPS board is actually faulty and we need to get a replacement. So this is the capacitor that we need to replace. It's an Elite 150 microfarad 450 volt electrolytic capacitor. We also need to be conscious of the dimensions. The replacement capacitor needs to be of similar dimensions in order that it fits onto the board. So what I'm going to do is I'm going to order a new replacement. When it arrives, I'm going to put it on the board. I will carry out some preliminary checks to ensure that there are no shorts. As you saw from my testing, the fuse was not blown, so I don't think there are any other shorted components. But we do need to replace this, do a preliminary check for shorts, and then try power it on. Please like and subscribe if you like what I do, and I will be back with another video next week.